Hey guys, so we're going to be doing question 19 right now. So I already did question 18, which in there I showed you how to draw the resonance structures for them to prove that SO4 had four equivalent resonance structures. So I'm not going to redo drawing the resonance structures, but I will show you how all the XO, like all the bonds are the same length. Because 19, oh my gosh, 19, the answer is going to be B, so we know it's going to be all, so I'm going to show you why it's all. But I'm also not going to take the time to redraw the structures, just if you forgot, watch that video. So for NO2, it's NO2 minus. Oh my gosh. Sorry, guys. I'm best at drawing straight lines. So this is the first option. So for question 19, it says, in which of the ions do all the XO bonds indicates the center atom have the same length? So it's asking between these two, why if the length between this oxygen and the nitrogen and this oxygen are the same length. So usually you might think, well, no, because double bonds have a shorter length than single bonds, but actually because it's a resonance structure and it can flip-flop like this, that means that they do have the same length, and that's kind of confusing, but it's just true. So if it was a normal non-resonant structure, like, give me a second. Actually, can't think of one. I don't know. Oh, okay. And Cl C or sorry, C Cl. And there's 3 here, 1 here. This would have a shorter length than this one because there's 3 bonds here and here. But since this is a resonance structure and they can flip-flop like this, that means that they're gonna have the same length, because when you draw the hybrid structure, which I don't think she ever really went over, but this is how you draw a hybrid structure. The hybrid structure, which means that this is how it looks when they flip-flop. Since it has that, then it's gonna have the same length. So that applies to all of them. So because they are resonance structures, that means that even though they're gonna have a mix of double bonds and single bonds, since the bonds can flip around anywhere, they're all gonna have the same bond length. If it's not a resonant, if the bonds don't have resonance, like you can't flip them around, you can't, like, for example, the CNCl, then there's difference in bond length. I don't know if that makes sense. Hopefully it does. But because they're resonance structures and because the bonds can flip like this, they're gonna have the same length. So that's what it is for all of them, because all 5 of those are are molecules that have resonance structures. I hope that made sense. If it doesn't, email me. Have a good day.